So this is the first video of your midterm review that is apparently happening on Monday. So first thing that I want to review is Avogadros number is 6.02 times 10 to the 23, and that's a number you have to have memorized. And the units that are associated with it are particles, which is the sciencey word for things, atoms, which are used for single elements, molecules, which is used for covalent compounds, and formula units, which are used for ionic compounds. Now, knowing which one is used for what is not particularly necessary for your midterm, but you do need to know that all four of those words, if you see them in your question, that's a big indicator that you're going to need to use Avogadros number in a T-chart. So for example, if it says how many atoms of copper are in 5.3 moles of copper, the key things that we want to see here is that I'm given 5.3 moles of copper and I want atoms of copper. Now, because we're talking about copper the whole question through, it tells you that it's only going to be a one-step problem, that you're not going to have a multi-step T-chart. Okay, so we always start off by making our T-chart and putting what we have in the beginning. So 5.3 moles of copper. Now, we always know that whatever unit and chemical we have, it repeats itself on the bottom. And because we know that it's a one step, because we're talking about copper the whole time, that tells us that the atoms of copper will go on top. Now, Avogadros number, which is 6.02 times 10 to the 23, particles, atoms, molecules, formula units, all of that is always equal to 1 mole. And so we know that Avogadros number will go next to where we have written atoms, and 1 goes next to mole. Okay, anytime you're talking about the same element every single time, moles is always 1. And so then we put this in our calculator. Remember that if the number is on the top, you multiply by it. So it'll be 5.3 times Avogadros number divided by 1. So 5.3 times 6.02 times 10 to the 23 is equal to 3.19 times 10 to the 24. Remember, a lot of your calculators will have it as 3.19 with maybe some extra numbers, and then I'll say E24. Okay, remember that E is times 10. Okay, that's what that means. So our answer is actually 3.19 times 10 to the 24 atoms of copper, because our moles of copper cancel out. Okay, now it could ask you a very, very similar question, but just opposite, where we're still dealing with moles and Avogadros number, but in this problem, we are given 6.78 times 10 to the 23 molecules of CH4, and they're asking for moles of CH4. And again, because we're talking about CH4 the entire time, it's a one-step problem. So we set up our T-chart, 6.78 times 10 to the 23 molecules, which you can't really shorten because otherwise it would just say moles and that gets confusing. CH4, put it in the T-chart, and I follow my pattern. You have to follow the pattern, otherwise you'll never get it. So we write molecules on the bottom, and I know that anytime I see the word molecules, Avogadros number has to go next to it. And because it's a one-step problem, I just write what I'm looking for on the top, moles of CH4. And we know if I'm not changing the chemicals, it's always 1 mole. Avogadros number is always equal to 1 mole. So in this case, we're actually going to be multiplying by 1 and dividing by Avogadros number. And the reason that we knew that this time we have to divide is because we followed our pattern of where our units have to go, right? Whatever you're given, that's how you know what goes on the bottom, and that sets up your problem. If you do not do that, then you will accidentally multiply when you should have divided, or you will divide when you should have multiplied, all of that sort of thing. And so what we get is we get 1.13 moles of CH4. And so that is how you use Avogadros number in a T-chart. Pretty basic in terms of that, just memorizing the number and making sure that you follow your pattern. Okay, so let's take a look at molar mass. So remember, molar mass comes up all the time, so it's something to remember and keep up with. So in molar mass, your molar mass is always equal to 1 mole. So Avogadros number was equal to 1 mole, molar mass is equal to 1 mole. Okay, and so when you're calculating molar mass, you're trying to figure out, remember, mass is measured in grams. So we're trying to figure out the grams of calcium nitrate in 1 mole. And so we do that by going to our periodic table. Anytime you see grams in a T-chart, you go to your periodic table every single time. And so what we're going to do is we're going to list out our elements. So I have calcium, I have nitrogen, and I have oxygen. And we count how many we have. Remember, if you don't see a number, then it's 1. So I have 1 calcium, there's a 1 after the nitrogen. Okay, so I have 1 calcium. Now, the 2 outside the parentheses gets distributed inside. So I'm actually going to have 2 nitrogens and 6 oxygens. We multiply by their mass on the periodic table. So calcium is 40.08, nitrogen is 14.01, and oxygen is 16.00. So this will stay the same. 2 times 14.01 is 28.02, and 6 times 16 is 96. So then we add them all together to get our final part. And so we have 40.08 plus 28.02 plus 96 will give us 164.10 grams. And remember, that's always equal to 1 mole, which is why we would normally write our molar mass as being 164.10 grams per mole. Because chemists, remember, are lazy, we don't write ones, and so there's that invisible 1 there, saying it's always how many grams are in a mole. Okay, so just keep that in mind. And so we can use that in a problem like the one we have below. It says how many moles of calcium nitrate are in 50 grams of calcium nitrate. So again, some key things to point out. They're asking for moles of calcium nitrate, and we're given 50 grams of calcium nitrate. Because I see that I'm talking about calcium nitrate the entire time, it is a one-step problem. So I put what I have, 50.0 grams of calcium nitrate first in my T-chart. And I repeat my pattern. I know that if I have grams of calcium nitrate there, that it has to go on the top. Or excuse me, it has to go on the bottom diagonally from it. That these two things have to match always, otherwise my problem is doomed. Okay, now I also know that because it's a one-step problem, I can just put what I'm looking for on the top, so moles of calcium nitrate. And so I know, again, one step, it's always 1. And my molar mass will go next to grams. Anytime you see grams in a T-chart, that's your molar mass, your periodic table, which we calculated earlier to be 164.10 grams. So we multiply by 1 and divide by our molar mass. So 50.0 divided by 164.10 will give us 0.30 moles of calcium nitrate. Okay, so that's our first problem. Now we can also combine it, right, where we have Avogadros number and molar mass. So for example, in this question, it says how many atoms of carbon are in 25 grams of carbon. Now, again, because I'm talking about carbon the entire time, I know it's a one-step problem. So I put 25.0 grams of carbon divided by, I follow my pattern, I put grams of carbon at the bottom, and I put what I'm looking for on the top only because it's a one-step problem. I'm talking about the exact same chemical the whole question. It's always carbon. Okay, so if I see grams, I know that's molar mass. So I have carbon, I only have one of them, it's 12.01, so it stays 12.01, and there's nothing to add. I put 12.01 next to grams, and I know that anytime I see atoms, that automatically means Avogadros number. Now, you might be saying, but I thought all those other problems, they had moles, but it's a one-step problem, and moles is not mentioned in the question, so we can actually bypass it because both of these things are equal to 1 mole, and that means they're also equal to each other. And so when we do this problem, okay, we know that we're going to multiply by Avogadros number and divide by our molar mass, and we should get 1.25 times 10 to the 24 atoms of carbon. Okay, and so this is for unit 7. These were the T-charts that we were focusing on, were these. Okay, now obviously you remember stoichiometry, unit 8. What if you're not talking about the same chemical the whole time? And they do get more complicated, but this is the basics of unit 7, and I will in the next video talk about empirical and molecular formula and percent composition, which was the other part of unit 7. Good luck.